7 days ago, something changed. On November 5, 2025, observers watching 3I Atlas expected a predictable fade. Instead, they witnessed something no one saw coming. This wasn't supposed to happen. Interstellar visitors don't behave this way. When 3I Atlas approached the Sun, astronomers prepared for a routine observation. A distant traveler from beyond our solar system making its closest pass. Nothing more. But on October 29th, as it reached perihelion, the object flared. Not gradually, violently. Its brightness doubled in hours, defying every thermal model we've built. And then it stayed bright. Days passed. The glow persisted. That plateau of light, that refusal to fade, became what scientists now call the perihelion brightening anomaly. At first, they thought it was a mistake. Calibration error. But observatory after observatory confirmed it. Subaru in Japan, Las Cumbres Network, the European Southern Observatory, all saw the same thing. The object was getting brighter as it moved away from the Sun. That breaks the rules. Comets brighten before perihelion, then fade always. 3I Atlas refused. And here's where it gets stranger. There was no dust. Spectrometers detected powerful gas emissions, cyanogen, hydroxyl ammonia, but polarimetry showed almost nothing solid. No dust grains scattering light, just gas. Pure, fluorescing vapor pouring into space without dragging debris along. For comet scientists, that changes everything. It means the surface isn't behaving like ice. It's behaving like a sealed reservoir finally cracking open. The data from November 1st showed the light curve had doubled over just 2 days. Yet the gas-to-dust ratio was 20 times higher than any known Oort cloud comet. 20 times. This wasn't a dirty snowball melting. This was something else entirely. Teams at Harvard ran thermal simulations. At perihelion, surface temperature should have peaked around 230 Kelvin, cold enough to sublimate carbon monoxide and carbon dioxide, but nowhere near hot enough to explain the water vapor surge instruments were recording. That means the interior was pre-conditioned. Millions of years of galactic cosmic rays likely hardened the outer shell, trapping volatiles beneath a radiation-scarred crust. When sunlight finally penetrated, the release wasn't random, it was controlled. The word controlled sparked immediate debate. Some interpreted it as evidence of self-regulated venting, gas escaping through fractures that opened in sequence as the body rotated. Others called it coincidence, a complex dance between orientation, chemistry, and heat. But the images from NASA's SOHO observatory told a different story. The coma wasn't diffuse, it was elongated, almost filamentary, like a directed stream rather than a cloud. Solar Orbiter confirmed it. As 3I Atlas passed, plasma instruments detected fluctuations in the solar wind. The gas wasn't scattering randomly, it was columnar, coherent. One reviewer quietly remarked it resembled an artificial venting pattern more than a chaotic one. No one dared say it louder. Not yet. 3 competing theories emerged. The subsurface pressure burst hypothesis suggested heat built beneath the crust until trapped gases erupted. The layered sublimation model proposed alternating bands of volatile and solid material vaporizing in sequence. The electrostatic discharge idea claimed intense solar radiation ionized the surface, releasing energy through plasma-driven erosion. Each explained part of the data. None explained all of it. The pressure burst predicts a brief spike. 3I Atlas showed a slow, sustained rise. The layered model fits the gradual increase, but not the extreme gas ratio. The discharge theory matches the spectral signatures, but can't account for the water vapor spike detected by ALMA. That surge, 40 times the perihelion output, remains the hardest data point to reconcile. By November 5th, most institutions agreed on one statement: 3I Atlas did not explode. It experienced an event that fundamentally altered its reflective and emissive properties. Whether thermal, structural, or something entirely unknown, it challenged every assumption about how ancient interstellar material reacts to solar heat. And then there was the gas itself. Subaru's spectrometer caught deep absorption lines. Carbon dimer, ammonia, hydroxyl radicals, classic volatile breakdown, but again, no dust. The James Webb Space Telescope added another layer: strong water vapor, ethane, traces of methanol, all from a confined region. Yet the thermal curve stayed flat. The gas was escaping cold, not from heating, but from internal pressure or chemical reactions within the crust. This pattern, gas without dust, isn't entirely new. Comets like 96P Mach-Holes and C2016 R2-Pass show high gas ratios, but nothing approaches the extreme of 3I Atlas. At perihelion, there was complete absence of continuum scattering. No solid matter at all, just vapor. The European Southern Observatory proposed an explanation. Cosmic radiation over millions of years compacted the outer layers into an organic, rich crust. Radiation transforms simple ices into tar, like residues. This crust sealed interior volatiles. When sunlight reached it, only trapped gases could escape, seeping through microscopic pores without dislodging fragments. James Webb's infrared data showed spectral features consistent with long-chain hydrocarbons. Materials formed only after prolonged radiation processing. Another group suggested the lack of dust links to the body's origin. If 3I Atlas formed around a red dwarf with different elemental ratios, its ices could contain more volatiles and less silicate dust. The carbon to oxygen ratios retrieved from JWST already differ from known solar system comets. Its chemistry was shaped under conditions we've never seen. But the dustless nature created a problem. Without dust, optical telescopes struggled to measure size and rotation. Researchers had to use spectroscopy alone, inferring rotation from gas intensity fluctuations. Early results suggested about 8.5 hours, consistent with the light curve oscillations. Then Solar Orbiter's magnetometer recorded something unusual, a transient magnetic field fluctuation coinciding with the gas outburst, faint but distinct, a ripple in the local plasma as if the escaping gas was ionized and interacting with the solar wind in a coordinated way. Normal comets generate broad, irregular plasma tails. This signal was narrow, directional, extending directly along the object's path. Some scientists are revisiting electrochemical comet models, bodies where charged particle interactions trigger volatile release without heat. These models were fringe decades ago. 3I Atlas has revived interest. High-energy cosmic rays could have created trapped charge zones inside the crust. When solar radiation reached those layers, sudden discharges might have released both energy and gas. Clean, bright emission without particulate debris. Skeptics argue simpler. 3I Atlas could be very fine, grained ice that sublimates directly into vapor without forming cohesive dust clumps. A rapid transition from frozen to full outgassing once sunlight penetrated deep enough. Such processes exist in carbon dioxide-dominated comets. But the difference is scale. 3I Atlas's spike was far larger than any CO2 event on record. Ultraviolet observations noted strong hydroxyl emission at 309 nanometers. Direct sign of water breakdown. Yet no scattering signature from solids. Gas was venting through a clean process. No silicate features which would indicate dust. For planetary scientists, the implications are profound. If interstellar bodies release gas without dust, our detection methods may need to change. Most survey telescopes rely on reflective dust. A dustless object could pass unnoticed, invisible to traditional searchers but active in infrared or radio bands. As of November 5th, the race continues. James Webb monitors infrared emissions. Hubble plans new imaging to measure any delayed dust release. So far, none has appeared. The coma remains clear, thin, sharply defined, not a shroud of dust, an invisible envelope of vapor. In the hours after the perihelion flare, solar observatories captured something that became the focal point of every analysis. A long, asymmetric glow trailing 3I Atlas as it curved past the sun. It looked like a coma at first, but different, narrow, stretched, directional, more stream than cloud, and it stayed stable for nearly 8 hours. SO's LESCO C3 chronograph caught the clearest sequence. Between 8 a.m. and 4 p.m. UTC on October 30th, the glow expanded into an elongated plume roughly 5 times longer than the nucleus diameter. But brightness increased sharply on one side. The opposite flank stayed dark. Azimuthry suggested channeled flow, a jet or narrow fissure directing the release. Frame by frame analysis revealed subtle fluctuations, pulsed emissions, not continuous outgassing. Regular rhythm hinting at rotational venting, but the periodicity didn't match. Pulses were too slow. Instead of the estimated 8-hour rotation, the emission rhythm appeared closer to 12 hours. Either the spin slowed dramatically at perihelion or another process modulated emission. Both remain possible. NASA's Solar Orbiter, 60 million kilometers away, detected a faint secondary plume, short vertical streak visible only in extreme ultraviolet. It persisted about 2 hours before fading. Together, the twin plumes gave the coma strange, almost mechanical symmetry, like twin exhaust trails intersecting at the nucleus. No one claims controlled emissions, but the geometry is unlike anything seen before. The Max Planck Institute constructed a model based on known rotation, solar flux, and nucleus size, estimated between 800 meters and 1.2 kilometers. If a hardened crust fractured along a longitudinal fault, venting could become columnar. As the body rotated, sunlight periodically heated that fracture, producing a directional jet. Multiple parallel fractures combined could create a narrow plume appearing stable from Earth. That fits the data partially. But the coma maintained shape even moving away from the sun. Normally gas plumes dissipate quickly under solar wind pressure. 3I Atlas's plume remained coherent far longer, implying ionized molecules constrained by magnetic fields. When Solar Orbiter's magnetometer recorded a sharp fluctuation as the plume appeared, researchers suspected plasma-driven dynamics. Plasma tails aren't uncommon, but the field alignment was peculiar. The coma didn't follow solar wind flow. It pointed several degrees off axis, roughly aligned with the object's motion vector, not the sun's magnetic field lines. Flowing along the path it traveled, not away from the sun. That mismatch puzzled heliophysicists. One explanation: the object itself carried a residual magnetic field, perhaps acquired during its interstellar journey through charged particle-rich regions. Such a field could locally deflect ionized gases, shaping motion independently of solar wind. Optical observations from Las Cumbres revealed another anomaly. The coma displayed faint reflective sheen, but only within a specific wavelength range near 550 nanometers, consistent with thin metallic or mineralized grains, possibly sodium or magnesium compounds dispersed throughout the gas, concentration too low to be visible as dust, but sufficient to scatter specific colors, giving the elongated tail a faint green hue through sensitive filters. Japan's Solar Observation Unit performed modeling. A venting column carrying vapor mixed with ionized metals could sustain linear structure through electromagnetic confinement. Charged particles within the jet interact, creating a self-stabilizing plasma sheath resisting dispersion. The result: a narrow, persistent beam aligned with motion. By November 1st, several preprint analyses suggested the elongated coma might indicate not explosion or structural failure, but controlled outgassing tied to orientation. As heat reached deeper layers, multiple vents may have opened sequentially, producing symmetrical plumes merging into one formation. If the crust contained radiation, processed organics acting as insulators, those could delay volatile release until critical alignment, but Caltech's infrared laboratory urged caution. Data quality near the sun is difficult to interpret. Solar glare, instrument scattering, background plasma can distort apparent shapes. The elongated structure could be projection effect, illusion created by perspective as the object moved across bright solar background, a standard gas plume viewed edge on. What is certain: the geometry added new dimension to discussion, no longer just chemical oddities. Now morphology entered spotlight. A narrow, stable, elongated coma implies ordered venting behaving more like repeating mechanism than random eruption. As the elongated coma began fading, astronomers expected emissions to subside naturally. Instead, another anomaly emerged, this time in water vapor lines. ALMA detected sudden dramatic rise in the 556.9 GHz line associated with hydroxyl production, direct indicator of water vapor photodissociated by sunlight. Over 48 hours, inferred water output jumped nearly 40 times higher than pre-perihelion level. Sustained through the first week of November, ground-based observatories in Hawaii, Chile, Spain confirmed independently. Spectral profiles showed deepening OH absorption bands, widening hydrogen lines, large quantities of ice converting directly to vapor. But temperatures across the coma remained low, around 200 Kelvin, far below what would be required for such powerful outburst. Vapor was being released not from surface melting, but from pressure venting or phase transitions within interior. If 3I Atlas spent millions of years exposed to interstellar radiation, its outer crust thickened into dark carbon-rich shield. Beneath, volatile ices would remain sealed under immense pressure. Once crust fractured during perihelion heating, sunlight could penetrate those layers, triggering sublimation cascade. Jets would erupt through cracks, venting gas in surges appearing as steady emission increases to distant observers. James Webb's mid-infrared spectrometer strengthened this picture. October 30th to November 3rd revealed strong rotational bands of H2O-CO2, CH3OH with almost no continuum brightness change. Ratios imply gases originated deep within nucleus, not from surface ices. Perihelion peeled back the object's skin, exposing pristine material untouched since formation beyond our solar system. Yet even this theory leaves questions. Water release rate exceeds what standard energy balance models allow. According to ESA's preliminary report, solar energy absorbed at perihelion could only account for roughly 1/10 of measured vapor flux. That discrepancy implies either internal heat source, chemical or radioactive, or exothermic reaction triggered as fresh ice met sunlight for the first time in millions of years. One possibility involves trapped carbon monoxide and methane reacting with oxidized minerals inside crust. When these gases encounter sunlight or heat, they ignite mild oxidation chains, releasing energy and freeing bound water molecules. Laboratory simulations at Southwest Research Institute show such reactions can sustain vapor production far beyond solar heating alone. Another theory focuses on structural collapse. As outer layers fractured, pockets of pressurized ice might have destabilized, causing internal caverns to implode and expose fresh, volatile surfaces. This cascading collapse would continually open new channels for sublimation, creating illusion of steady rising output. The light curve supports this. Multiple minor peaks superimposed on main rise, consistent with sequential venting. There's also a more radical interpretation. A few researchers point to timing of water surge, roughly 12 hours after elongated coma reached maximum extension, as evidence of delayed heating from beneath crust. If sunlight penetrated through newly formed plume, it could have focused energy back onto nucleus, accelerating sublimation. feedback loop creating runaway phase transition where deeper layers suddenly vaporized, releasing enormous water without raising surface temperature. This would fit the timeline perfectly. Would also account for continuing low dust levels, ejected gas escaping through pre-existing pores too small to lift solid particles, 3I Atlas venting like a geyser, not exploding like a comet. By November 4th, Hubble joined mapping the expanding gas cloud. Ultraviolet imaging confirmed hydroxyl emissions spread outward to more than 50,000 kilometers radius. Despite enormous expansion, density remained unexpectedly uniform, no filaments or clumps, smooth even glow. That symmetry was almost as puzzling as the spike itself. Release occurred evenly across surface, or gas somehow stabilized after emission. University of Arizona proposed photochemical recombination could be responsible. As sunlight broke down water molecules into hydrogen and hydroxyl, some recombined almost immediately, maintaining equilibrium and keeping brightness steady. Would explain why coma appeared so homogeneous even as it grew, but would require near-perfect balance of temperature and radiation. Unlikely coincidence, without some form of self-regulating mechanism, the increase in water vapor had measurable effects on surrounding solar environment. Parker Solar Probe detected faint but distinct rise in local hydrogen density as it passed near ecliptic plane during early November. Though not confirmed as originating from 3I Atlas, timing aligns closely. If correlation holds, it would mean emissions were strong enough to measurably influence solar wind hundreds of thousands of kilometers away. Rare feat for any comet, let alone interstellar one. The question now dominating discussion: what the spike reveals about interior composition. Every indicator points to layered body, dark radiation, processed crust, transitional zone rich in organic compounds, deeper core of pure ice preserved since formation. Sudden eruption of water suggests crust finally breached into inner reservoir, exposing most ancient material within. Unprecedented glimpse into chemistry of matter formed in another star system, but not everyone agrees. Some researchers argue water data could be skewed by contamination from solar background emissions or overestimation of molecular fluorescence efficiency. Others point out similar spikes seen in solar comets that simply fragmented, possibilities still under review. If a portion of 3I Atlas broke apart during perihelion, fresh surfaces could have ignited surge. So far, no telescope detected separate fragments. Nucleus remains intact, suggesting objects survived whatever caused spike. By end of first week of November, water output began stabilizing, though still far above pre-perihelion levels. Scientific consensus describes event not as explosion, but as global activation, moment when object crossed thermal and structural threshold, revealing interior to sun for first time. What began as simple flare evolved into most detailed chemical portrait of interstellar body ever recorded. Yet even as water emissions continued, James Webb began detecting something deeper. Beneath gaseous glow, faint thermal anomalies hinted at internal layering, zones of differing temperatures that could reveal how crust evolved under cosmic radiation. If correct, those readings might explain not only spike, but object's entire strange behavior since arrival. As James Webb continued tracking 3I Atlas through early November, its instruments uncovered patterns invisible to optical observatories. The mid-infrared instrument recorded thermal emissions at wavelengths between 10 and 20 microns, mapping temperature gradients across faint coma and nucleus. What they found changed discussion completely. Rather than smooth temperature curve like ordinary comet, 3I Atlas showed sharp discontinuities, pockets of heat separated by cold zones. Nucleus appeared to have two distinct layers, warm, thin outer shell and much cooler core. That temperature split was unexpected. Suggested outer shell was absorbing sunlight efficiently, but conducting almost none inward. Surface acted like insulator. When data were analyzed at Space Telescope Science Institute, researchers estimated insulating layer thickness between 15 and 20 meters. Beneath it, core remained colder than models predicted by nearly 30 degrees. That discrepancy could only be explained by presence of dense radiation, hardened crust formed over millions of years, as cosmic rays bombarded object during long interstellar journey. Such crust isn't new idea. Laboratory experiments show when ice rich in carbon monoxide, methane, ammonia is exposed to energetic particles, it gradually polymerizes into complex hydrocarbons, forming tar-like material known as tholin. Over time, this residue darkens and becomes extremely resistant to heat. On 3I Atlas, that process likely continued for eons, sealing interior beneath tough organic layer capable of withstanding temperatures that would destroy most comets. This explains strange behavior at perihelion. Crust delayed sublimation until sunlight finally penetrated deepest cracks, allowing trapped gases to erupt suddenly rather than gradually. Once breached, those internal layers released volatile compounds in massive quantities, producing flare and water spike observed after October 29th. Infrared spectra from JWST also revealed absorption lines corresponding to aromatic hydrocarbons, complex ring-shaped molecules forming only under prolonged radiation exposure. These compounds concentrated near surface, fading sharply at greater depths. That gradient suggests outermost material is ancient and heavily processed, while deep ices remain pristine. For planetary chemists, that distinction is critical. Direct glimpse into molecular composition of matter formed around another star long before birth of our solar system. Object's unique crust also sheds light on why coma was so poor in dust. As radiation transformed outer layers, it likely compacted and fused remaining silicates into dense matrix. When sublimation began, gas could seep through microscopic pores without dragging solid grains along, would produce exactly the dustless emission pattern seen during perihelion event. Even more intriguing were subtle variations in infrared brightness across surface. JWST's imaging revealed bright patches, localized hotspots interspersed among colder regions. These could represent fracture zones where sunlight penetrated deeper into crust. Their alignment roughly matched orientation of elongated coma recorded earlier, suggesting bright plumes originated from those same weak points. Some researchers believe these fractures act as thermal valves. When internal pressure builds, gas escapes through them in bursts, cooling surrounding crust and temporarily sealing vent again. Cyclic behavior could explain steady but pulsed light curve recorded after perihelion, pattern seeming too regular for random sublimation. At Harvard's Department of Astronomy, Ivy Loeb's team analyzed JWST data and proposed controversial idea that crust might function almost like self-regulating shield. If cosmic radiation over millions of years altered materials' electrical conductivity, surface could accumulate static charge. When sunlight hit, localized discharges might puncture crust, releasing gas in rhythmic intervals. Loeb emphasized this doesn't imply artificial design, but could point to unknown electrochemical mechanism at play on ancient interstellar objects. For now, community remains divided. Conservative interpretation sees 3I Atlas as natural relic, ancient body whose hardened shell simply delayed awakening. More daring view suggests objects' physical responses are too structured to be purely random. Both camps agree, however, that JWST's findings provide clearest evidence, yet that interstellar visitors carry complex geological and chemical histories unlike anything native to our system. Discovery of multi-layered crust also affects how future missions might approach similar objects. Any spacecraft attempting to sample material from interstellar body would need to drill through tens of meters of irradiated organics before reaching pristine ices beneath. This insight could shape design of next-generation probes, particularly those aimed at capturing interstellar dust or flyby samples. But for now, most pressing question is how crust reacted during perihelion flare. Did it rupture in single event or melt from within as sunlight triggered internal chemical reactions? Answer could determine whether 3I Atlas experienced natural outburst or something closer to structural failure. To find out, scientists turn to another clue hidden in timing and shape of flare itself, precise moment when object's brightness peaked and heat distribution changed. Data show rapid synchronized shift across multiple wavelengths, as if entire surface reacted in unison. Whatever caused it happened everywhere at once. It began at 1642 UTC on October 29, 2025. Data from NASA's SOA coronagraph, ESA's solar orbiter, multiple ground-based observatories all recorded same flash. Abrupt increase in visible light lasting less than 2 minutes. No fragmentation. No debris. No shockwave in surrounding plasma. Yet object's total brightness jumped measurably. Spectral lines shifting in intensity across every instrument observing it. To naked eye, it would have looked like faint pulse. Heartbeat of light against sun's glare. To astronomers, something far stranger. In hours that followed, instruments tracking event noticed another anomaly. Temperature distribution on surface, previously stable, had inverted. Cooler core suddenly warmed by nearly 20 Kelvin, while outer shell cooled. That reversal occurred almost simultaneously across all hemispheres, implying event wasn't localized. Entire body reacted at once, as though internal shock propagated through it. James Webb's infrared readings captured change in extraordinary detail. Just before flash, spectrum showed weak water lines and relatively flat thermal curve. Minutes after, water signature intensified sharply, joined by spikes in carbon dioxide and cyanogen emissions. Shape of curve implied gas expanded outward at high velocity, around 800 meters per second, before stabilizing. Yet no signs of fragmentation appeared. Object remained intact, silhouette unchanged. This is why scientists began calling it perihelion shock. Sudden whole body reaction looking like explosion but leaving no visible damage. Theories rushed in. First proposed mechanism: rapid phase transition within crust. Under intense solar heating, amorphous water ice can transform into crystalline ice, releasing trapped gases. That transformation releases latent heat capable of generating pressure waves strong enough to cause brightness jump observed by SOHO, but calculations showed volume of gas required to produce observed luminosity was too large for this explanation alone. Second hypothesis emerged from plasma physicists studying solar orbiter data. During flash, spacecraft's magnetometer recorded brief disturbance in surrounding magnetic field, ripple coinciding perfectly with optical brightening. That signal suggests 3I Atlas may have discharged large amount of ionized gas all at once, temporarily coupling with solar wind. Object behaved like natural capacitor releasing stored charge, could explain simultaneous nature of event. Once electrostatic potential reached critical threshold, discharge propagated across entire surface nearly instantaneously. If true, would mean 3I Atlas spent years accumulating electrical charge during journey through interstellar space, only to release it when solar radiation ionized crust. Idea remains controversial but has gained traction among heliophysicists, noting such discharges observed on smaller scales in comets approaching Sun. None, however, shown this level of synchronization. Meanwhile, spectroscopic data from ALMA provided another clue. Right after flare, new molecular species appeared in spectra. Formaldehyde, acetylene, traces of ammonia hydrate. These compounds can form when radiation, processed organics are suddenly heated and react with water vapor. Presence suggests shock may have fractured outer crust, exposing subsurface material to sunlight for first time. Pattern fits idea of thermal snap, phenomenon where rapid temperature gradients create mechanical stress fracturing body from within. When crust of 3I Atlas cracked, volatile gases trapped underneath would have vented explosively, releasing both energy and molecules previously sealed for millions of years. Once pressure equalized, emission stabilized, explaining smooth decline in brightness that followed. However, some researchers at NASA's Goddard Space Flight Center argue uniformity of event cannot be explained by random cracking pattern. Simultaneous timing across entire surface implies global trigger, not local failure. Their analysis points to resonant effect. As object rotated, sunlight heated specific regions in sync with internal vibration frequency. When resonance is aligned, stored mechanical energy released in single pulse. If confirmed, would be first time such resonant thermomechanical event ever observed in interstellar body. Still, electrostatic discharge model remains most discussed. Evidence for plasma interaction is difficult to ignore. During flash, solar orbiter's plasma analyzer registered spike in high-energy electrons moving outward from object. Signal lasted only few seconds but carried distinct profile, sharp onset, exponential decay, alignment with object's path. Looked remarkably similar to signatures produced by lightning, like discharges in dusty plasma environments. If 3I Atlas's crust was electrically charged, perihelion shock could have been release of accumulated energy in single global arc. For mission scientists, this raises profound questions about physical nature of object. Could interstellar travelers accumulate charge as they drift through galaxies' magnetic fields? Could that energy influence behavior when entering new stellar environment? These questions now central to study of extrasolar objects. In days after flash, observations continued around clock. Brightness plateaued but didn't fade completely. Coma remained elongated. Gas composition stabilized into steady mix of water, carbon dioxide, trace organics. No dust fragments appeared, no debris trails formed. Nucleus maintained rotation period of roughly 8.6 hours. For object that just experienced global discharge, it appeared astonishingly stable. On November 2nd, European Space Agency released preliminary summary. 3I Atlas experienced sudden energy release near perihelion consistent with internal gas venting or plasma discharge. No evidence of fragmentation or material loss detected. Something inside object released energy, but gently enough that body survived intact. Discovery has implications far beyond single object. If other interstellar visitors carry similar crusts, many could undergo comparable events when encountering sunlight first time. Each would reveal glimpse into alien chemistry and physics we can't reproduce in laboratories. Yet most striking part of perihelion shock isn't what it tells us about 3I Atlas's structure, it's what it implies about its future. After flare, object's brightness didn't return to pre-perihelion baseline, remained elevated as though persistent venting process begun. Ongoing activity means shock didn't destroy 3I Atlas, may have awakened it. As it moves outward, continuing to release gas in smaller pulses, scientists now studying how orbit and velocity respond. If those parameters shift in ways inconsistent with pure gravity, would confirm perihelion shock triggered sustained outgassing capable of propelling objects slightly, just as spacecraft adjusts course. In first week of November, as observatories scrambled to analyze after effects of perihelion shock, flow of new information began to slow. Teams sharing near, real-time updates suddenly went quiet. NASA's Deep Space Network stopped releasing telemetry timestamps from solar orbiter plasma instruments. Minor Planet Center's photometric updates, previously published every few hours, delayed by days. Even James Webb's raw data pipeline for 3I Atlas observation sequence showed gap, frames missing from expected schedule. For public following event, seemed like nothing was happening. Inside research community, became clear something very much was. First sign came November 3rd when Space Telescope Science Institute temporarily restricted external access to JWST's 3I Atlas data under what it described as priority analysis. That term usually applies to planetary defense cases or events with potential impact risks, not scientific curiosity. Decision triggered immediate speculation. Researchers analyzing perihelion flare found archive links inaccessible overnight. Internal sources confirmed NASA and ESA conducting coordinated data review before releasing anything further. Officially, agency cited data verification. Perihelion shock occurred under extreme conditions, close to sun's glare with high background interference. Before publishing, teams wanted to ensure calibration accuracy. Unofficially, scientists began to suspect withheld data contained more than noise. Multiple observatories detected low-frequency electromagnetic fluctuations during flare. Some readings were unusually coherent. If those signals proved real, they'd demand explanation beyond standard comet physics. By November 4th, frustration among independent astronomers spilled into open. A.V. Loeb of Harvard's Galileo project published open letter calling for immediate public release of all 3I Atlas data. Scientific method depends on transparency, he wrote. If 3I Atlas represents new class of interstellar objects, world's researchers must have full access to its signatures. Within 24 hours, statements signed by more than 80 scientists across 15 institutions. Despite that, NASA maintained data hold, citing need to protect instrument integrity during reprocessing. European Space Agency took slightly different approach, releasing limited telemetry summaries but withholding high-resolution spectra. Justification echoed NASA's. Signal-to-noise ratio was poor and premature publication could lead to misinterpretation. Yet inside astronomy community, private conversations revealed growing concern agencies not only protecting data, but protecting narratives. Some suspected pattern of electromagnetic readings might hint at structured periodicity. Something couldn't easily be dismissed as random plasma noise. Worth emphasizing, no evidence supports artificial behavior. Scientific process requires caution. But secrecy always invites imagination. Forums and research boards filled with speculation, claims of deliberate maneuvering, encoded signals, directed energy emissions, most quickly debunked. But fact agencies withheld data only fueled public curiosity. For independent observatories, situation simpler but equally frustrating. Smaller facilities continued tracking 3I Atlas after perihelion, submitting data through open networks, yet contributions largely ignored by major institutions. Observers in South Africa and Argentina reported minor deviations in objects' light curve, suggesting slow rotation shift, but without access to James Webb calibration data, couldn't confirm it. Meanwhile, inside NASA's Planetary Defense Office, internal memo leaked through informal channels hinted at another reason for data freeze. Memo stated spectral line coherence at 21 centimeters remains under analysis. 21 centimeter band is frequency commonly used in radio astronomy to study neutral hydrogen. Also frequency of deep interest in search for technosignatures. When asked directly, NASA declined comment, calling statement speculative. Still, reference enough to ignite week of debate in scientific press. While conspiracy theories spread online, real scientists continued working quietly. By November 5th, internal cross-agency group formed, including representatives from NASA, ESA, Japan's JXA, tasked with correlating all plasma, optical, radio data from perihelion window. Their goal? Determine whether low-frequency signals were artifacts or genuine emissions. Early leaks suggest most apparent coherence may indeed stem from interference, likely from solar wind turbulence rather than object itself. But until full data release occurs, nobody can say for certain. Tension underscores deeper issue in modern astronomy, balance between transparency and caution. When data involve interstellar objects, bodies that may represent first solid evidence of material from beyond our solar system, scientific conservatism collides with public expectation. Every delay, every withheld image becomes fuel for speculation. A.V. Loeb's team denied access to JWST's raw frames, turned instead to public data from Solar and Heliospheric Observatory. Using open algorithms, they reconstructed brightness curve of 3I Atlas across perihelion window. Their analysis, published in preprint form November 5th, concluded light spike followed pattern consistent with non-random release event, meaning timing of emissions appeared structured rather than chaotic. Paper doesn't claim artificiality. Merely states pattern was unusually regular, possibly due to internal rotation coupling. Still, it reignited debate and placed pressure on NASA to clarify findings. Behind scenes, insiders describe growing unease within agency teams. JWST's engineers, who rarely engage with policy, instructed to reprocess 3i Atlas data with new noise filters before public release. Normally, that step takes days. In this case, extended to weeks. Some staff expressed concern bureaucratic caution interfering with scientific urgency. For public, story beginning to resemble old pattern. Discovery, shock, silence. It happened with Oumuamua in 2017 when unexplained acceleration led to endless speculation. Happened again with Borisov, whose structure defied early modeling. Now happening with 3i Atlas, most closely observed interstellar visitor in history. Once again, crucial data held back until review committees agree on official narrative. But science rarely stays contained long. Independent tracking networks continue gathering light curve data, citizen scientists compiling them into open archives. Pattern emerging from those observations suggests 3i Atlas still active, brightness fluctuating gently every 8 to 9 hours, consistent with rotation and periodic venting. Whatever agencies withholding, unlikely to remain hidden indefinitely. Still, for professional astronomers, immediate concern not secrecy, its accuracy. Question now dominating every private discussion, same one that's defined object from start. Is 3i Atlas behaving according to natural laws we already know, or revealing new physics we don't yet understand? That uncertainty divides the field. Some see perihelion event as powerful reminder of how limited our models truly are. Others, more cautious, warn that extraordinary claims require extraordinary proof. For now, all agree on one point. Until full data are released, every theory, no matter how grounded or radical, remains speculation. When official data streams fell silent, scientists turned inward, back to what they could verify. In laboratories and observatories around the world, teams began testing natural explanations that could reproduce strange series of events witnessed at 3i Atlas's perihelion. Task was simple in outline, but nearly impossible in detail. Fine chain of natural processes that could create gas, rich flare, dustless coma, global thermal inversion, and synchronized flash of light, all without breaking apart object. First hypothesis to gain traction was CO2 cooling cap model. Begins with assumption that 3i Atlas's surface, hardened by millions of years of cosmic radiation, contained layers of carbon dioxide ice beneath tar, like crust of complex organics. As object neared Sun, outer layer would have softened, allowing trapped CO2 to escape gradually. That escaping gas would cool surface, effectively insulating deeper water ice layers beneath. Then, as CO2 depleted, shield would vanish, exposing hidden ices to direct sunlight. Within hours, temperature would surge, producing sudden outgassing spike detected after perihelion. Explosion wouldn't be violent, would be slow thawing of frozen reservoir finally reaching light. To test this, planetary chemists at Max Planck Institute simulated carbon dioxide crust under vacuum conditions matching object's environment. Result was promising. Crust did form temporary cooling barrier. When it sublimated, deeper ice layers reacted explosively to heat change. But timescale was wrong. In laboratory, transition occurred over minutes. In space, based on 3i Atlas's trajectory, would take days. Model could explain general behavior, but not sudden global response seen during perihelion shock. Second natural theory focused on rotational stress. 3i Atlas spins roughly once every 8.6 hours, relatively fast rotation for body its size. When icy objects rotate that quickly, even small internal density variations can create enormous mechanical tension. Over time, these tensions build until fractures propagate across crust. If multiple cracks formed at once, especially near perihelion when thermal expansion was highest, they could release buried gases almost simultaneously, creating coordinated flare. Support for this model came from European Southern Observatory's light curve data. Amplitude of objects' brightness oscillation shifted slightly since July, implying subtle change in shape or orientation that could indicate structural stress building internally. Still, model leaves one major question unanswered. Why didn't any fragments detach? Most comets suffering rotational failure shed visible pieces. 3i Atlas remained intact. Either its crust was exceptionally strong or stress dissipated through gas release rather than mechanical breakage. Third possibility emerged from thermal, chemical perspective. Some researchers propose shock was triggered not by mechanics or heat, but by chemistry. Over long periods, cosmic rays can split molecules in ice, producing reactive radicals like hydrogen peroxide. These radicals remain stable in cold vacuum of interstellar space. But when warmed, they recombine explosively, releasing oxygen and heat. If 3i Atlas's interior contained even small fraction of such compounds, wave of recombination could sweep through subsurface once temperature rose above critical threshold. That chain reaction would release gas and heat nearly simultaneously, matching brief optical pulse seen at perihelion. To evaluate this, scientists at Jet Propulsion Laboratory modeled thermal conductivity of hydrogen peroxide, rich ices exposed to solar radiation. Simulation showed shallow recombination front could indeed move through crust at speeds high enough to produce global response. However, model requires concentration of reactive compounds far greater than typically found in solar system comets. If 3I Atlas formed in different stellar environment, one rich in ultraviolet radiation, those conditions might be plausible, but confirmation will depend on new spectral data remaining under review. Other more conventional explanations also considered. Flare could have been phase change cascade where internal ices of different composition vaporized in sequence, each triggering next. Could also result from solar wind compression, transient surge in plasma density focusing around object as it crossed magnetic boundary. In that case, flash might not have originated from object at all, but from space immediately surrounding it. Timing of magnetic ripple recorded by solar orbiter lends slight credibility to this interpretation, though doesn't account for subsequent spike in water vapor. Prevailing consensus, if one can call it that, is cautious. Most scientists now describe perihelion event as multi-factor process. Thermal stress, chemical activation, electrostatic discharge likely all contributed. Global shock could have been combined outcome of internal gas pressure, surface cracking, electrical discharge through ionized vents. In this view, event was extraordinary, not because it was unnatural, but because it combined so many rare natural mechanisms at once. Conditions only interstellar object could host. One thing nearly all researchers agree on, 3I Atlas's crust plays central role. Without that hardened layer, none of these effects would manifest in such synchronized way. Crust acts like timing mechanism, delaying release until last possible moment, then channeling energy through confined pathways. Its strength explains why object didn't fragment under stress. Instead of shattering, it flexed, vented, resealed. Efficient, almost self-protective process. Astronomers comparing 3I Atlas to comets within our own solar system note its endurance defies precedent. Even 96P Machaul's, one of toughest known comets, loses material rapidly during perihelion. 3I Atlas endured flare that should have destroyed it. That resilience could mean interstellar objects, shaped by harsher cosmic environments, possess mechanical properties far beyond our expectations. If that's the case, phenomenon witnessed in late October might represent natural awakening of body evolved under alien physics rather than any artificial event. Yet conversation rarely ends there. Each natural explanation brings scientists closer to understanding what happened, but not why objects' behavior appears so precise, so measured. Its thermal inversion, symmetric coma, even distribution of gases all hint at order rather than chaos. Some argue order can emerge naturally from complexity. Others suspect we may be looking at something engineered by nature herself on scale we don't yet understand. For months before perihelion, scientific conversation around 3I Atlas stayed mostly within boundaries of physics and chemistry. But after perihelion shock, as natural explanations began to strain against precision of data, small but growing number of researchers began entertaining another possibility. That object's behavior might not be entirely natural. No one suggested extraterrestrial design outright. But language in some papers shifted subtly. Self-regulating emission, coherent structure, directed venting. Words once belonging to engineering now appeared in scientific abstracts. Most prominent voice in this camp was A.V. Loeb. Having already proposed Oumuamua might have been thin artificial solar sail in 2017, Loeb argued 3I Atlas's symmetry and energy release timing demanded serious open-minded consideration. In interview on November 4th, he pointed out that nature is messy, rarely coordinates. Brightness pulse of 3I Atlas, he said, behaved like system that was waiting for threshold. He didn't call it machine, but emphasized such behavior consistent with intentional activation or programmed venting. Other theorists approached question more cautiously. SETI Institute's internal analysis described flare as mechanical in appearance, but explainable through layered geophysical coupling. Still, phrasing reflected unease. Event symmetry, absence of fragmentation, persistence of elongated coma resembled control rather than chaos. In natural objects, activity tends to follow random fractures. In 3I Atlas, emissions appeared synchronized, as though regulated by internal mechanism. Separate study by French astrophysics team examined perihelion light curve at sub-second resolution. They identified micro-oscillations repeating every 0.38 seconds during flare's peak, too fast to be explained by rotation and too regular to be noise. Pattern resembled repeating waveform fading as coma expanded. Team labeled it quasi-periodic plasma resonance, though privately several members admitted it looked engineered. When data submitted for peer review, oscillation section removed at editor's request, pending confirmation. Structural argument for artificiality rests largely on crust itself. If cosmic radiation built out a shell of tholin-rich material, crust should display irregular fractures. But high-resolution infrared mapping shows evenly spaced thermal hotspots distributed almost geometrically. One possibility. Internal layering caused heat to escape through preferred channels. Another. Those channels are physical conduits. Critics of artificial hypothesis dismiss second option as anthropocentric bias, tendency to see design in symmetry. Yet even they admit 3I Atlas's uniformity is exceptional. Engineers at European Space Operations Center added technical perspective. If object's interior contains cavity network formed by differential sublimation, then venting would occur through repeated pathways producing appearance of coordination. But if those cavities were aligned by common axis, as observations imply, would require extraordinary coincidence. One that in artificial theory circles has become centerpiece of debate. There are more speculative claims, though they remain outside peer-reviewed literature. One proposes 3I Atlas could be passive probe, derelict device designed to absorb energy until activation. In this model, perihelion shock wasn't failure, but trigger. Moment sunlight reached buried threshold sensor. Others suggest it could be engineered relic, perhaps once part of larger structure, now eroded into something barely functional. None of these theories supported by physical evidence. They persist mainly because data gaps leave room for interpretation. Even those open to artificial possibilities acknowledge danger of confirmation bias. Human mind craves pattern and purpose, especially when faced with phenomena seeming to defy randomness. Cautionary example remains Oumuamua, object once hailed as possible technology, but later reinterpreted as natural hydrogen iceberg. For many astronomers, that episode serves as reminder that extraordinary claims must withstand ordinary scrutiny. Yet artificial hypothesis has forced legitimate questions. Why did light curve plateau so evenly? Why did emission stabilize rather than decay? Why did coma align with direction of motion, not solar wind? Each detail has natural explanation, but none explain all of them together. Loeb summarized it best. If this is natural, it's type of natural we haven't met before. Still, mainstream view remains grounded. Scientists at NASA's Goddard Space Flight Center emphasize that every anomaly so far, from gas composition to plasma behavior, fits within extreme limits of natural chemistry and physics. Unusual coordination could stem from rotational harmonics, surface heterogeneity, or coincidental phase transitions. In short, nature is still likeliest engineer. Regardless of which camp one joins, debate itself has become historic. Never before has interstellar visitor provoked such simultaneous fascination and caution. And as new instruments continue tracking 3I Atlas on outbound leg, next test will come not from theory but from motion. As perihelion event faded into archives, solar orbiter, Parker Solar Probe, several ground-based radio arrays kept focus on objects' outbound trajectory. By November 5th, new kind of anomaly began to emerge, subtle, almost invisible to optical telescopes, but unmistakable in plasma data. Interstellar Traveler was leaving behind disturbances in solar wind that didn't match its size or composition. Parker Solar Probe was first to notice. Passing through region of inner heliosphere not far from 3I Atlas's projected path, instruments registered sudden drop in proton density, followed by ripple in magnetic field, pattern similar to that produced by coronal mass ejections, except no ejection occurred. Disturbance seemed to originate near object's coordinates. Day later, ESA's solar orbiter detected same phenomenon from different angle, confirming event wasn't artifact. Something around 3I Atlas was altering solar plasma flow. This wasn't unprecedented. Comets known to form magnetic drapes, thin sheets of charged particles deflecting solar wind as gas interacts with sunlight. But geometry here was unusual. Magnetic deflection extended far beyond what small gas-emitting body could sustain, almost 10 times expected radius. Even more curious, disturbance wasn't constant. It pulsed every 8 to 9 hours in rhythm with object's rotation. Magnetic field fluctuated as though 3I Atlas was exhaling periodically into solar wind. Researchers at Johns Hopkins Applied Physics Laboratory analyzed data and concluded objects' gas jets were likely ionized enough to create transient magnetosphere, bubble of plasma briefly resisting sun's influence. For body less than kilometer wide, that's extraordinary. Implies escaping gases carried significant electrical charge, likely energized by interactions between solar ultraviolet light and metallic ions within vapor. If so, then 3I Atlas wasn't just reflecting sunlight, actively sculpting surrounding environment. Further evidence came from Budayan spacecraft near Earth's orbit, which detected faint radio emissions in kilohertz range synchronized with timing of magnetic ripples. These emissions resembled natural plasma oscillations, electromagnetic waves produced when charged particles oscillate in magnetic fields. Similar signals recorded around comets before, but never with this level of coherence. Pattern appeared organized, stable, almost harmonic, in technical terms too clean. To understand how interstellar object could produce such ordered plasma behavior, scientists turned again to crust described in earlier chapters. Surface rich in conductive organics or metallic residues could accumulate charge as solar radiation strikes it. When gas escapes through venting fractures, those same vents might act as plasma channels, releasing bursts of ionized material coupling directly with magnetic field. Result would be periodic emissions perfectly aligned with rotation, natural generator switching on and off as object spins. In principle, such system could even generate small but measurable thrust. Ionized jets, though faint, impart momentum. Over time, that momentum can alter trajectory. When mission planners recalculated 3I Atlas's post-perihelion path using latest optical data, they found discrepancy. Tiny but statistically significant. Object was drifting slightly off predicted course, deviating by roughly 0.01 astronomical units over 2 weeks. Too small for panic, too large to ignore. Models that once fit perfectly now required subtle corrections. To most astronomers, explanation was straightforward. Asymmetric outgassing. When gases escape more strongly in one direction than another, they act like miniature thrusters, pushing nucleus in opposite direction. Same phenomenon seen in comets across solar system. But 3I Atlas's case was different in one crucial respect. Its venting was synchronized, not random. That means thrust, however weak, was consistent. Over months or years, such precision could accumulate into significant course alteration. Meanwhile, radio telescopes from Carl G. Jansky Very Large Array began monitoring region for plasma echoes, reflections of low-frequency waves bouncing through objects' ionized tail. Data showed faint repeating bursts at roughly 9-hour intervals matching known rotation rate. No message, no modulation, nothing artificial, just rhythm. Kind of rhythm nature sometimes produces by accident, but which humans instinctively recognize as design. Physicists studying emissions proposed 3I Atlas might be functioning as natural plasma resonator, structure that traps and releases electromagnetic energy as it spins. Such systems exist in laboratory plasmas and around large magnetized planets, but never observed on body this small. If confirmed, discovery would open an entirely new field of heliophysics, showing interstellar debris can carry active electromagnetic dynamics shaped by millions of years of exposure to cosmic radiation. Still, not everyone convinced signals intrinsic to object. Some argue they could be artifacts of solar interference, coincidence in timing, or instrumental harmonics caused by spacecraft calibration. Others counter multiple independent instruments across different missions and distances detected same periodicity, making random error unlikely. For now, scientists agree only on one fact. 3I Atlas is interacting with solar wind in ways never before documented for object of its size and origin. It's not inert, it's active, reactive, complex. Whether that complexity stems from natural plasma physics or something more exotic remains open question. By mid-November, object's distance from Sun had grown, visible brightness began to fade. Yet low-frequency signals persisted faintly, like echoes slowly drifting into outer heliosphere. Periodic pattern grew weaker but stayed in phase, as though 3I Atlas continued to breathe, maintaining same silent rhythm even as it receded into darkness. For mission controllers, implications are immense. Every anomaly, light curve, dustless gas, magnetic pulses, points to same conclusion. This is not passive rock from another star. It is active, evolving system responding to sunlight, magnetism, pressure in ways that challenge current physics. And while question of artificiality divides scientists, question of activity no longer does. 3I Atlas is alive in mechanical sense, energetically, dynamically, chemically alive, and as it drifts farther from our telescopes, that realization has reshaped how researchers define activity in interstellar space. Because what began as distant flare near Sun has now turned into sustained transformation. Object isn't dimming way it should. Its light remains steady, its course subtly altered. Something continues to drive it outward, and every new data set suggests same quiet truth. Whatever happened at perihelion wasn't end of story, it was beginning of motion. As of November 5, 2025, astronomers watching 3I Atlas with mixture of relief and confusion. Interstellar object survived close pass by Sun intact, yet its motion since perihelion event no longer fits projections calculated before October 29. Small differences appearing between predicted and observed positions. Differences too consistent to be simple measurement noise. Las Cumbres Global Network, Subaru Telescope in Hawaii. Several ESA tracking stations all reported gradual offset in object's right ascension and distance. Minute, measured in hundreds of kilometers. But in celestial mechanics, that amount over only few days implies active forces still at play. Simplest explanation is continuing gas release. Invisible engine producing gentle thrust as object rotates away from Sun. Infrared readings confirm faint plumes persisting from two narrow regions on surface. They vent mostly water and carbon dioxide, sometimes mixed with trace ammonia. Each emission peaking roughly every 8.5 hours. Same rotation period recorded before perihelion. Activity is subtle. No visible tail appears in optical images, but mid-infrared glow reveals pockets of heat pulsing in rhythm. Whatever triggered brightening on October 29th is not finished. Models built at NASA's Goddard Space Flight Center show even trickle of gas escaping at few hundred meters per second could alter trajectory by measurable amounts. When that gas is ionized, solar wind amplifies effect, adding momentum each time vent faces sun. In effect, 3i Atlas behaves like natural plasma thruster, small, steady, perfectly timed with its spin. Preliminary recalculations now place outbound velocity slightly higher than before perihelion, though margin remains within error bars. What is certain is direction. Deviation points precisely along axis of earlier jet, not perpendicular to it. That alignment rules out random fragmentation and points toward controlled venting shaped by object's own rotation. Spectroscopy adds another layer of mystery. Balance of molecules in gas has shifted since flare, hydroxyl and cyanogen lines weakening while faint traces of silicate vapor appear. Evidence venting now eating deeper into crust. Radiation processed surface eroding, exposing more primitive layers beneath. Each new pulse reveals material untouched for perhaps billions of years. Observers describe current phase as post-perihelion drift, quiet but revealing stage where small changes in brightness and motion expose objects' internal architecture. Light curve analysis from Nordic Optical Telescope shows tiny modulations repeating with remarkable regularity, almost like heartbeat. Those fluctuations probably correspond to surface topography, valleys, fissures, vents rotating into sunlight one after another. With enough data, researchers hope to reconstruct crude map of nucleus, identifying precise regions responsible for continuous thrust. Meanwhile, space weather monitors continue detecting faint electromagnetic wake following object. Solar Orbiter's magnetometer still records low-frequency ripples trailing along 3i Atlas's path, subtle echoes of stronger plasma interactions that flared during perihelion. Strength of those ripples decreases each day. Yet persistence confirms body remains electrically active, in essence still coupled to solar wind. At European Space Operations Center, orbital dynamics teams began updating long-term projections. Escape trajectory now slightly steeper relative to ecliptic, meaning object will leave solar system bit earlier than expected if current outgassing continues. Difference measured in weeks, not months. But it carries weight. Every alteration tells scientists how much energy remains locked inside this interstellar remnant. No evidence points to fragmentation or structural collapse. Optical imaging from Hubble taken November 4th shows single intact nucleus with faint halo roughly 50,000 kilometers across. Brightness curve smooth, rotation stable, surface still releasing gases in measured rhythm. For something that endured global shock only days ago, 3i Atlas appears astonishingly composed. Consensus forming among researchers is that perihelion event wasn't destructive explosion, but transition. Shift from dormancy to slow sustained activity. Object now self-venting in equilibrium, converting internal pressure into momentum without destabilizing structure. This is unprecedented behavior for any known comet or interstellar visitor. In quiet terms, 3i Atlas is still alive, changing shape, shedding layers, subtly steering itself through inner solar system. Each new measurement suggests continuity, not decay. Perihelion shock didn't end story. Began second phase. Error of motion shaped by object's own reactions to sunlight and plasma. For scientists watching from observatories across Earth, this drift is gift of time. Means 3i Atlas remains active enough to study for several more weeks before fading into deep space. Every spectrum captured now, every pulse of infrared light carries information from body older than our sun and stranger than any comet yet known. Now that 3i Atlas entered calm outbound drift, focus of nearly every research team shifted inward toward core that endured it all. Everything object has done since discovery seems to circle back to one question. What lies beneath that hardened shell? Surface with its radiation, scorched crust and narrow vents already revealed traces of tholins, carbon monoxide, silicate vapor. But these only outermost clues. Beneath them may rest oldest material humanity ever observed, matter forged before birth of our sun. James Webb Space Telescope continues providing best window inside. Using near-infrared spectrograph, scientists comparing emissions from cooling coma to laboratory spectra of known ices. Results suggest multiple internal zones, each chemically distinct. In uppermost layer, processed crust. Dominant features are complex organics, aromatic hydrocarbons, nitriles carbon chains baked by cosmic radiation into dark insulating shell. Below that, transitional region appears to contain volatile ices mixed with clays and silicates frozen together like sediment in ancient rock. And at deepest detectable level, Webb's data hint at something purer. Crystalline water ice laced with ammonia, methane, traces of carbon monoxide. Signature seen only in coldest molecular clouds between stars. If those readings correct, 3i Atlas carries time capsule of pre-solar chemistry. Deeper layers formed in environment colder than anything in present, day solar system, possibly within disk of another star or in raw molecular cloud that birthed it. Isotopic ratios recovered from preliminary spectra already differ slightly from local standards. Deuterium levels in released water vapor appear elevated, matching values seen in interstellar ices rather than in comets from our Oort cloud. That single measurement, if confirmed, would make 3I Atlas most pristine piece of interstellar matter ever studied. Researchers describe its internal structure as onion-like, built from successive epochs of exposure and protection. Outer crust, about 15 to 20 meters thick, is product of long radiation bombardment. Beneath it, pressure and cosmic compression may have created compact crystalline matrix keeping inner core sealed. This architecture, part geological, part chemical, allowed object to survive perihelion shock intact. Instead of shattering, crust flexed and vented, preserving nucleus beneath. Laboratory analogues on Earth help illustrate how unusual this resilience is. When scientists at Southwest Research Institute recreated similar radiation cycles on icy samples, they found organic, rich crusts normally crack under thermal stress after few years of simulated exposure. 3I Atlas, by contrast, appears to have held together for millions of years. Key may lie in microcrystalline silicate threads embedded within organic shell. Webb's polarization data shows subtle signatures consistent with such inclusions. Fine mineral fibers strengthening crust, much like rebar reinforces concrete, if verified, would suggest this interstellar traveler not only chemically alien, but mechanically exceptional. Next mystery involves temperature. Even after flare, core remains far colder than models predict, about 160 Kelvin, too low for sustained sublimation. Yet emissions continue. One explanation is internal conduction delay, heat from perihelion shock still migrating inward, releasing volatiles as it moves. Another proposes chemical reactions inside crust, generating localized warmth, maintaining outgassing without raising bulk temperature. Both mechanisms imply nucleus not inert but thermally dynamic, evolving even as it recedes. Every new dataset deepens sense that 3I Atlas is more than wandering chunk of ice. It is geological system. Miniature world whose surface records violence of interstellar travel, while core preserves stillness of creation. In past week alone, infrared spectra revealed subtle oscillations in brightness that may correspond to internal layering, like seismic echoes in solid planet. Some analysts interpret them as evidence of cavities or density contrasts. Others caution they could be artifacts. Either way, prospect of internal complexity inside 1 kilometer object challenges simplicity with which we've always imagined interstellar debris. Implications reach beyond astronomy. Chemists studying data believe 3I Atlas may hold prebiotic compounds, molecules that could seed life when delivered to young planets. Its outer shell, rich in nitrogen and carbon chains, resembles feedstock for amino acids. If such material drifts regularly between star systems, then ingredients of biology not isolated to any one world, they move freely through galaxy carried by bodies like this one. As of tonight, November 5, 2025, object continues to fade slowly, but remains within reach of JWST's instruments. Each spectrum captured now is glimpsed little deeper into that ancient heart, portion that no sunlight ever touched directly. Within weeks, it will dim beyond detection, its secrets locked again in silence between stars. But before it vanishes, leaves behind something permanent. Proof that interstellar matter is layered, reactive, enduring. Not static fragments, but evolving systems shaped by time and radiation. Now that first phase of 3I Atlas analysis stabilized, astronomers turn to comparison. This is not first time interstellar object crossed our solar system, but first to reveal such extraordinary behavior under sustained observation. By placing 3I Atlas beside its predecessors Oumuamua in 2017 and 2I Borisov in 2019, scientists beginning to outline broader pattern, one that may redefine what we mean by interstellar visitor. Oumuamua the first was riddle of motion. Discovered October 2017 by Pan-STARRS survey in Hawaii, showed no visible coma, no dust, no gas, yet it accelerated as if pushed by something invisible. Brightness varied sharply every 8 hours, suggesting long tumbling shape. Spectral reflectivity pointed to dry metallic or rocky surface. That acceleration sparked endless debate. Some said caused by outgassing too faint to detect. Others, including A.V. Loeb, proposed it might have been thin and flat, propelled by sunlight like sail. But whatever it was, Oumuamua left solar system without revealing secret. 2 years later came Borisov, and with it relief. It looked like comet, diffused dusty, full of cyanogen and water vapor, behaved naturally, as though to remind scientists most wanderers just frozen remnants of other star systems. Yet Borisov carried different clue. Dust grains exceptionally small and uniform, finer than anything seen in local comets. That uniformity suggested formation in unusually cold, low turbulence region of space. Perhaps young planetary disk far from any star's heat. 3I Atlas bridges gap between them. Has Borisov's chemical activity, but Oumuamua's mystery of controlled motion. shines like comet, but behaves like engineered system. Crust hides deep ice. Coma is thin and almost dustless. Venting is rhythmic rather than random. In sense, it unites contradictions of its predecessors, half natural, half unknowable. When plotted together on single chart, mass, albedo, rotation, acceleration, the three form sequence. Oumuamua, driest, reflects sunlight like metal. Borisov, wettest, behaves like classic comet. 3i Atlas sits between them. Mixed composition, mixed behavior. This progression may not be coincidence. Could represent different stages of exposure to interstellar radiation. Body that spends millions of years adrift between stars will harden, darken, lose volatiles, becoming inert. Another that leaves its system more recently may still carry ices and organics. In that sense, 3i Atlas could be transitional object. Midlife interstellar traveler caught between comet and relic. What makes it stand apart, however, is endurance. Both earlier visitors, short, lived in observational terms. Oumuamua passed within 0.5 astronomical units of Sun and vanished in weeks. Borisov fragmented soon after perihelion. 3i Atlas, by contrast, not only survived encounter but emerged brighter, venting in organized pulses that continued days later. That resilience suggests structure far stronger than porous ice. Perhaps compression and radiation fused its materials into single composite. Part rock, part organic polymer, held together by chemistry of time. Comparative studies also show 3i Atlas emits gas at cooler temperatures than either predecessor. Water vapor lines remain strong even at distances where other comets would have frozen solid. Means it traps heat efficiently or maintains internal reactions, keeping sublimation alive. If interstellar objects can retain this kind of internal energy, then their journeys through space might not be passive drifts at all, but slow chemical evolutions. Each flare, each spike in vapor could mark step in transformation from living chemistry to fossil record. Researchers already rethinking classification. Until now, categories were simple. Asteroidal for dry, inactive bodies like Oumuamua, cometary for active, icy ones like Borisov. 3i Atlas defies both. Neither fully inert nor fully volatile. Neither dusty nor smooth. Its behavior demands new term, one proposed quietly in recent ESA paper, reactive interstellar object. Term reflects what these bodies appear to be. Not fragments or visitors, but catalysts reacting dynamically to new environments. Idea carries profound implications. If interstellar objects evolve chemically as they travel, then each system they pass through leaves fingerprint, layer of minerals, ices, or radiation scars accumulating over eons. By studying them, humanity isn't just learning about distant worlds, reading record of galactic time. 3i Atlas, with its stratified crust and enduring activity, could become first complete sample of that cosmic archive. Already plans forming for missions that could intercept future visitors. Concepts for fast propulsion probes modeled on solar sail or nuclear electric designs being re-examined with 3i Atlas in mind. Challenge is speed. These objects move faster than any spacecraft humanity ever launched, but potential reward is incomparable. Single grain of unaltered interstellar ice could tell us whether chemistry across galaxy follows same rules as ours, or if life's building blocks differ from star to star. Comparisons also carry emotional weight. Oumuamua's mystery left lingering sense of frustration. Borisov's beauty offered comfort. 3i Atlas given both, elegance of order and discomfort of not fully understanding it. Each of these visitors reminds us galaxy alive with motion, that fragments of other worlds drift constantly through our sky, and we catch only few. For now, scientists speak of 3i Atlas as bridge between known and unknown, between natural and engineered, between past of Oumuamua and future of whatever comes next. It has shown interstellar bodies not uniform. They are diverse, active, and in some cases seemingly self-regulating. As object fades into outer system, its comparison to predecessors serves final purpose. Perspective. We've now observed 3 messengers from beyond Sun, each stranger than last, and if cosmic statistics hold true, more will come. Some dry, some volatile. Perhaps one carrying clues even deeper than these. By November 5th, data flood surrounding 3i Atlas slowed to cautious trickle, object itself receding, fading into cold arc beyond orbit of Mars. But conversation it started anything but quiet. Inside laboratories, observatories, agencies, growing chorus of voices demanding transparency. Scientists calling this moment crossroads of truth. Test not only of what humanity knows about cosmos, but how it handles discovery. At center of this call is data embargo still surrounding JWST and solar orbiter recordings. Many astronomers now argue events' complexity, dustless coma, coordinated venting, electromagnetic signatures, requires full global collaboration. One researcher from ESA put it bluntly in private briefing leaked to press. We are no longer dealing with anomaly. We are dealing with new category of interstellar behavior, and it belongs to all of science. Avi Loeb and his Galileo project team been loudest voices in movement. They've petitioned NASA to release raw spectroscopic frames from perihelion window along with calibration files and unprocessed magnetic readings from solar orbiter. Their argument simple: without unrestricted access, independent verification impossible. Loeb insists secrecy, however well-intentioned, risks creating very myths agencies hope to avoid. Public is not afraid of mystery, he said during interview earlier this week. They're afraid of silence. NASA's official stance remains measured. Spokesperson confirmed data under review for instrument validation and will be released after noise reduction and consistency checks. Yet off record, several analysts admit real challenge is interpretation, not calibration. Magnetic anomalies recorded during perihelion event appear coherent, but not in any pattern known to plasma dynamics. Agencies want time to understand what they mean before unleashing speculation on global scale. Meanwhile, peer-reviewed papers emerging, each offering pieces of puzzle, but not whole picture. Max Planck Institute's publication describes 3I Atlas as layered volatile system undergoing post-perihelion activation. Harvard-Smithsonian team defines it as interstellar object with periodic non-gravitational acceleration consistent with anisotropic outgassing. Both descriptions technically correct and deliberately neutral. Neither addresses lingering question of why emissions were so precise, jet so stable, or brightness pulse so synchronized. Among scientists, split widening. Several organizations now taking steps toward coordinated transparency. International Astronomical Union proposed interstellar data charter.